Hello guys, welcome back to my channel Maison African Motives, as we shall be working on Mechanotechnics N4. So actually there are so many questions that have been asked on Mechanotechnics that we can just maybe focus on, which can be a benefit to us. So actually I'm going to focus on the precision measurement in this platform, working on the question paper which was actually written in February 2022. So we shall quickly rush through the questions that we had on precision and precision measurement. So in this case we had the question on which was on question 2. So if you're new guys, you can consider subscribing so that you won't miss any of the classes that we shall be having from Maison African Motives. Okay, so the first part of the question, we are given: use the dimensions of an internal duvet as shown in Fig 1 below to calculate the diameter of the roller used in test. You may make a neat sketch. You may make a sketch to assist with calculations. The dimensions are in millimeters. All right. So guys, that's it guys. As you can see, the diagram and the dimensions that we are given in millimeters there, and we want to calculate the diameter. Take note guys, what we need is to calculate the diameter in this case. All right, so let me just make another sketch. This is just a sketch guys. I don't know how it is going to look like, but let's just hope it is going to work from the explanations that I'm going to make here. All right, so this is what I'm having from my sketch here. Let me just put it this way. You understand me much better having a sketch, and you are supposed to make these sketches in pencil, and they're supposed to be very, very neat and clear. So in this case guys, it, as you can see, let's just put here all right, that's what we have in this case. All right, so this is what is happening here. These dimensions are in millimeters. All right, and we need the diameter in this case, which is actually the diameter. That's a distance from this point here up to this point here. That's a diameter. Or from this point up to this point. That's a diameter. But as we can see that most of the dimensions that we are given this length here from this point, which is 70.25 millimeters, and we are also given this one. So as we can see, we are given most of the length in this line, which is the horizontal line. So which means we can focus with this diameter here. It will be easier for us because we are given this distance from this point to this point, and all distance from this point to this point, which is also including the diameter here, because this part here is the end of the circle, so which means the diameter is included also. All right, so this is what is going to happen. The diameter in this case, we know that it's 2r. That is our diameter. Radius times 2, or radius is equal to diameter over 2. All right, so we have the radius here, the radius here. All right, so this is what I'm going to do on this sketch that we have drawn here. I'm just going to name the points like I have indicated there. All right, let's hope guys this is going to be neat. I don't know, but just see something and learn something guys. Okay, this is my sketch here. So let me just name some points so that I won't confuse you here like this. All right, this is what we have. Okay, from this point to this point here is this one that we are given, which is 70.25 millimeters. So let's just put this 70.25 millimeters. All right, this one like this. All right, and also this one on top is easier. Let's just put it 55.13 millimeters. All right, so this is what is going to happen guys here. Like I have explained that we have a radius and a radius here. So let's just name our points. Okay, so I'm just going to extend and name our points in this case. So I'm just going to extend here Okay, so I'm going to name a point at this point, a point at this point, a point at this point, and a point at that point, and another one here to make, like I said, we are going to focus with the horizontal line. So let's just focus with this line here. Let's just continue with this line here. So if we continue with this line like this, because it's also a horizontal, it can be easier for us to make adjustments from this. And as you can see, this is the radius from this distance, because this is your center here to this point, that's your radius. Okay, so let me just put this as my O to represent the center. All right, then we say this is the radius, this is the radius, like this. All right, so what is going to happen, this point corresponds to the end of the circle. So let's just name this point A, this point B, this point C, this point D, and the last point E. Okay, so you name these points according to the way that is good for you. And I'm going to name another one here. Let's just put our angle here. We had an angle of 60 degrees here. All right, and there is a distance of 35 millimeters here. So let's put this distance here. Let's put it here, from this point here to this point and this, so that we can form a right angle to triangle here. So this 35, we can just attach it to this point direct. Okay, so let's attach this. All right, let's just attach this like this, guys. All right, so I have attached my 35 millimeter here. All right, now it can make sense, because this is going to be a right angle triangle here, and if this is 60, which means I can also find this angle here. This angle is going to be from 180, because we know that angles in a triangle, they add up to 180. So that angle is going to be 180 degrees minus 90 degrees plus 60 degrees. All right, which is going to give us 30 degrees here. All right, so this is 30 degrees. All right, so I'm going to name also this point. So because we have a horizontal distance here, as you can see, because our major aim is having distances in the horizontal. So let's put another distance here. We are now at E, so you can just name this F and this as G, like this. All right, so remember, guys, the 53 millimeters was from this point up to this point, like this. This point here, this point here, this was our 53 millimeters, and we have got something from F to G, this one, that we can calculate, because it's also in the horizontal, just like this 53, just like this. So that is why we are focusing with this, not this one, but this one we are given, because that was our 35, that was our 35, this one, that was our 35 from this point up to this point. So this is our 35 millimeters here. All right, now I want us to relate the diagram to this part that we are having. If I'm to cross check it, I've got A, B, C. From A to B to C, like this. This is the diameter, this one, because it's radius plus radius. This is my diameter. But as you can see that this diameter is also part of this line, because it's included in this 72, and it's also included in this 53,1, because if you are to extend this line here, you will see that part of the diameter is also part of this 53,13 millimeters. So what am I going to do so that I can just remain with radius? Let us formulate an equation here, because we said that since, let's just write it down here, since AB is equal to, this AB is equal to BC, is also equal to the radius. So which means in place of AB, I'm going to put the radius. So let's form an equation using these letters, A to B to C to D to E. But this point, yes, we can just include this as BD. Okay, so let's just take this as from B to D, like this. Let's just combine this one so that it can be a special. I'm going to explain why am I combining this. Let's just leave the C part. These two are equal, but when combine from A to B to D and to E, this is going to give us 70,22. So which is AE. So in this case, AE is equal to from A to B, from B to D, and from D to E, because C is just part of the what? Because this BC and AB are the same. So just leave it like that. Use BD. Okay. So it's AB plus BD plus D to E. All right. This is what I formulated here. So now from this equation that I have, let's see what I have. AE, I have this AE. Okay, this AE is there. AB is the radius. Remember, we said AB here represents the radius. Okay, what about B to D? We do not have this one. So this one we do not have. What about D to E? D to E, we do not have again. This distance we do not have, but we can actually find this distance later on. I will talk about it, because as we can see from D to E, this distance, if you take it from F here, because this is E, so this E corresponds to this point. So F to E, that is the distance here of F to E. Subtract this FG here, you're going to remain with the DE. So which means, we can formulate an equation for that later on, but let's start with BD. All right, so how can we find BD? Which means we have to make some adjustments again, because this diagram is not enough. What further adjustments can be done? All right, these are the adjustments. Let's say we have bisected this, because this is a tangent, guys. As you can see from your some of these topics now, they like combine with your mathematics. There, from your mathematics, guys, you know that when you have got a tangent like this, when I draw a line from the center to the circle like this, it bisects this tangent, it bisects this angle into two equal parts. So if I am to draw such a triangle here from O to D like this, let me make adjustments like this, from O to D like this. Okay, then from O to B, I have made a triangle like that. All right, so this is now a triangle, this one. You see that this angle is now divided into two equal parts. This angle and this angle are equal. Okay, from that concept. And this angle at B is going to be 90 degrees. Why? From our concept again, a radius and a tangent. From your Euclidean geometry there, a radius and a tangent, they meet at what? They meet at 90 degrees. So which means there is a 90 degrees. So I'm just focusing with this one, not this one, because I want to find BD. All right, remember, from O to B is the same as from O to this point, and also from O to this point, which is also the radius. So which means, what about the angles now? All right, this is the concept. This angle here is 60 degrees, which means this whole angle combined together is going to give us 60 degrees. But we say these two angles are equal, so we are going to divide them, because we say this line is going to bisect, this one is going to bisect into two equal parts. But this angle is 60. Why? From your alternate angles, guys, remember, like this. If this is 60, this is also 60. From your alternate angles, or from your Z angles. So this is 60 here. As you can see, these lines are parallel, because this is a horizontal line and this is also a horizontal line. So this is going to give us 30 degrees, 30, because it's 60 divided by 2, which is 30. All right, so this angle here is going to give us 30 degrees, and this angle here is going to give us 30 degrees. Now my diagram is too small, or let me just put it here. Let me indicate it outside, but you know that it's inside here. This is our 30 degrees here, guys. Take note, inside this part like this, that's our 30 degrees here, inside this triangle or BD. Okay, I will redraw that triangle so that you can see properly later on. Okay, so since we want to calculate, because we said AB represents the radius, so we can find BD. Okay, this is our BD here. It's in the triangle or BD. All right, so let's find BD. All right, let's try and find BD. So find BD. All right, so how am I going to find BD? BD, I'm going to use triangle or BD. Okay, so use triangle or BD like this. All right, so this is our triangle or BD, this one. Okay, let's just take it like this. That's our triangle or BD. This one is like this. It's like this. Take note, guys. That's our O, our B, and our D here. And you say this is R because from the center to the circle, it's always radius. Okay, so OB is equal to R. Okay, so we need this one. We said is 30 degrees. That is the one that I was indicating, guys, but it's I've written it outside, but it's inside here. Remember, I told you that. All right, and we want to find this BD. All right, so we are now back to our mathematics, guys. What does our mathematics say on a triangle like this? This is the opposite and this is the adjacent. So from your mathematics, where there is opposite and adjacent, that's tan. From soccer tour, from your soccer tour there. So where there is opposite and adjacent, you use tan. So it's going to be tan 30 degrees, or let's just write the formula first. Tan 30, tan theta is opposite. That's opposite over adjacent, which is tan theta. Our opposite in this case is this side. That is your opposite, which is OB over BD. All right, so let's just substitute here, which is tan theta, which is 30 degrees, is equal to the opposite, which is our OB. So we can write this in terms of R, which is the radius, like this, over BD. And we want to find BD. So that means this time we are going to find BD in terms of R. All right, so let's just cross multiply here and find BD. So BD tan 30 degrees is equal to R. Then you can divide. So BD is equal to R over tan 30 degrees, like this. All right, so this is just same like 1 over tan. Okay, so 1 divided by tan is going to give us BD, 1 divided by tan. So if you divide 1 divided by tan, you are going to obtain tan 30, you're going to obtain square root of 3R, like this. Okay, because we just divided this, but there is R here, so it's square root of 3R, of which square root of 3 as a decimal is going to give us 1,732R if you round off properly. All right, so this is our BD in terms of R. But remember, why are we leaving this BD in terms of R? Because we said AB is equal to R. So BD in terms of R is fine, because remember, we said diameter is equivalent to 2R. So the moment we calculate this radius, we can simply multiply by 2. So that we now have the diameter, the one that we want to calculate. Okay, so this BD is now there. We are left with DE. All right, so what can we do to find DE? Okay, let's go back to our measure diagram. All right, our measure diagram. So I hope this one was clear. All right, so we're now going back to this, our measure diagram here. Okay, this is what we want to calculate, DE. So remember, guys, I told you about the relationship between this, because it's in the horizontal like this. From this point F to G, this distance here is the one that corresponds here. So it's the same as adding to DE to obtain this whole distance of 55,13. So that means let me write, that means if we add FG, this one, and DE, we are going to obtain this value here. All right, so FG plus DE. So this time we said we want to calculate DE. Calculate DE. So these are the stages that you're going to take. So FG plus DE, this one is going to give us this 55.13 millimeters. All right. Now this is it, guys. It's true that that's what we want. So let's just make DE the subject and see if we are going to win. So that means DE is equal to 55.13 minus FG, like this. But we do not have FG, guys. That's another story again. Where can we obtain our FG? We're going to use this triangle here. All right. So we do not have FG, guys. We do not have FG. So in this case, let's just write it here. Calculate FG. All right. So use triangle. Which triangle are we going to use? Let's use this triangle FGD. All right. So triangle FGD. So remember, we talked about this triangle before. So using this triangle, as we can see, according to this state, or you can use this 60, depends with which angle do you want to use. But as for me, I'm just going to use this state. Remember, we said angles in a triangle, they add up to 180 degrees. That's how we determine this state here. Remember the first state that I talked about, okay? Or you can just use this 60, it's one and the same thing. So if you use this 30, this is going to be your opposite here. And this is angle of 90, and the angle, so this is going to be your adjacent. But if you use 60 degrees, this 35 is going to be your opposite, and this will be your adjacent. Take note. All right, so here I said I'm using 30, so that's tan 30 degrees. Remember the ratio which is opposite and adjacent, guys, we talked about it. We said it's what? Tan. So it's tan 30 is equal to the opposite, which is FG, over the adjacent, which is this 35 millimeters that we are given, like this. All right, so that means someone can find FG here. Cross multiply 1 times FG, that's FG is equal to 35 tan 30 degrees. Okay, so from our calculator there, if we are to use our calculator properly, our FG is going to be 20.2025, something like that. Okay, so if you round off to 3 decimal places, it's going to be 207. Okay, that is our FG in this case in millimeters. So we have find FG, so we can now substitute, because remember our main aim is to have the value of what? Of DE. That is our main aim, or our main focus, or our main target. All right, so now let's substitute here. 55.13 minus FG, which is this FG here, 20.207. Okay, so we are going to obtain 34.923. All right, which is in millimeters. So we have determined DE in this case. All right, now let's go and perform the magics now from this part here. Let's try and perform our magics here, because we can see that all these values are now there. All these values are now there. The DE is there. Okay, so which means we can form an equation to find the value of R, because this one is also given in terms of what? In terms of R. So let's substitute, guys. AE from our diagram, AE is there. So this time it's just substituting AE. This is our AE, which is 70.2 is equal to AB. We said AB, that is from A to B, that is the radius. So it's R plus BD. Okay, guys, we calculated BD together, and this is what we obtained in terms of R. This was our BD here, so you still remember this one. So you're now going to substitute 1.732R plus DE. We just calculated our DE now this one. So you're going to substitute 34.923 like this. So you've formulated an equation there. we have formulated an equation there. Okay. Remember, if we can find the radius, therefore the diameter is there from this formula. So let's find R. Transpose. We are going to transpose this to the left hand side, so it's going to be a minus because it was a positive there. So it's 70,2 minus 34,923, which is equal to, we add these two, this one is same as 1 R plus, so it's 1 plus 1 comma, which is 2,732 R from your calculator. Okay, you subtract these two, you are going to obtain 35,327, which is equal to 2,732 R, like this. So definitely to find R, you have to divide. Remember guys, from your mathematics, you have to divide this. All right, so I now have the radius, which is these two divided together are going to give us 12,930819, something like that. Okay, so you can round off to 3 decimal places first, which is 123. So this is going to change it into 1, which is 12,931 millimeters. So this is the radius. But remember, the question is for us to calculate or to determine the diameter of the roller. Okay, which is the roller, this one used in the test, which is the diameter. So therefore, our diameter is going to be equal to 2 times the radius. So in this case, the diameter is equal to 2R, which is 2 times the radius, 12,931. Okay, so if we multiply this, we are going to obtain 25,862 millimeters. So that will be our diameter in this case. So as we can see guys, that's how we work on precision measurement. While you'll be asked to calculate different types of questions, to calculate the diameter, to calculate the height, sometimes to calculate the distance x. So there are so many questions. So we shall meet again in another class, working with the next question, still on the same topic and on the same question number 2 on a different platform from Mezon African Motives. Till we meet again.